This is my student support system. Keep watching, keep learning.
The liver is the largest gland of the body, weighing between 1 to 2.3 kilograms. It is situated in the upper part of abdominal cavity, occupying greater part of right hypochondric region, a part of epigastric region, and extending into the left hypochondric region. Its upper and anterior surface are smooth and curved to fit under the undersurface of diaphragm. Its posterior surface is irregular in outline. The liver is enclosed in a thin inelastic capsule and is completely covered by a layer of peritoneum. Folds of peritoneum form supporting ligament attaching the liver to the inferior surface of diaphragm. It is held in place partially by these ligaments and partially by the pressure of organs in the abdominal cavity. The liver has four lobes. The two most obvious, which are large, right lobe, and the smaller one is left lobe. The other two lobes are caudate lobe and quadrate lobe. This can be seen only from the posterior view, not in the front view. Here you can see this is front view, right lobe and left lobe, and this is posterior view, caudate lobe, this one, and this is quadrate lobe. Then there is portal fissure in the posterior surface. This is the name given to the region on the posterior surface of the liver where various structures enter and leave the liver. One is portal vein. Portal vein enters carrying blood from the stomach, spleen, pancreas, and the small and large intestines. The hepatic artery enters carrying arterial blood. It is a branch from the celiac artery, which is a branch of abdominal aorta. Nerve fibers, sympathetic and parasympathetic nerve fibers enter. Here you can see this is the hepatic fissure where all these nerves and vessels enter and leave the liver. The right and left hepatic ducts also leave carrying bile from the liver towards gallbladder. Lymph vessels leave the liver draining some lymph to the abdominal and some to the thoracic nodes. The falciform ligament extend from the undersurface of diaphragm between two principal lobes of the liver to the superior surface of liver, helping it to suspend the liver in the abdominal cavity. In the free border of falciform ligament, there is ligamentum teres or round ligament, which is a remnant of the umbilical vein in the fetus. Now we discuss the structure of liver. The lobes of liver are made up of tiny functional units called lobules, which are just visible to naked eyes. Liver lobules are hexagonal in outline. So these are like this and formed by cubical shaped cells. Here you can see these are the cubical shaped cells known as hepatocytes arranged in pairs of columns. Okay, so columns are there, pairs of column are there. Radiating from the central vein, there is a central vein here and they radiate outwards. These are the hepatocytes. So this is one lobule and they arrange in the like this, and finally the liver is formed. The blood drains from the sinusoids into central and centrolobular veins. These then join with the veins of other lobule forming larger veins until eventually they become the hepatic vein, which leave the liver and empty into the inferior vena cava. So here you can see this is the portal vein, this is the hepatic artery. So these eventually these blood unite here in the sinusoids and it passes towards hepatic vein, central hepatic vein, and during this process the exchange of nutrients and oxygen take place, and here in this duct canaliculi the bile is formed and collected in the bile duct and blood is drained in the hepatic vein. One of the function is of the liver is to secrete bile. Bile canaliculi run between the columns of liver cells. The canaliculi join up to form larger bile canals and then eventually they unite to form right and left hepatic ducts. These are right and left hepatic ducts which drain the bile from the liver to common bile duct and then to the gallbladder. Functions of liver. Liver is very active and it has a lot of functions to do. First of all, carbohydrate metabolism. The liver has an important role in maintaining plasma glucose level. After a meal, when the level of glucose rises, the glucose is converted to glycogen for storage under the influence of hormone insulin. Later, when glucose level falls, the hormone glucagon stimulates conversion of this glycogen into the glucose again, keeping the level within normal range. Next is fat metabolism. Hepatocytes store some triglycerides, break down fatty acids to generate ATP, synthesize lipoproteins, which transport fatty acids, triglycerides, and cholesterols to and from the body cells, synthesize cholesterol, and use the cholesterol to make bile salts. Protein metabolism. Hepatocytes deaminate means remove the amino group NH2 from amino acids so that the amino acids can be used for ATP production and converted to the carbohydrates or fats. The resulting toxic ammonia NH3 is converted into much lesser toxic urea which is excreted in urine. Hepatocytes also synthesize most plasma proteins such as alpha and beta globulins, albumin, prothrombin, and fibrinogens. Functions of liver continue. Processing of drugs and hormones. The liver can detoxify substances such as alcohol, excrete the drugs such as penicillin, erythromycin, sulfonamides into the bile. It can also chemically alter and excrete thyroid hormones and steroid hormones such as estrogens and aldosterones. Excretion of bilirubin. The bilirubin derived from the heme of aged and dead RBCs is absorbed by the liver from the blood and excreted into bile. Most of the bilirubin in bile is metabolized in small intestinal bacteria and eliminated in the feces. Synthesis of bile salts. Bile salts are used in the small intestine for emulsification of and absorption of lipids. Storage. In addition to glycogen, the liver is a prime storage site for certain vitamins like A, B12, D, E, and K, and the minerals iron and copper, which are released from the liver when needed elsewhere in the body. Inactivation of hormones. The hormones are inactivated or regulated by the liver. These includes insulin, glucagon, cortisol, aldosterone, thyroid, and sex hormones. Production of heat. Liver uses a considerable amount of energy, has a high metabolic rate, and produces a great amount of heat. It is the main heat producing organ of the body. Phagocytosis. The striate reticuloendothelial cells, which are also known as Kupffer cells in the liver, phagocytose the aged red blood cells, white blood cells, as well as some bacteria. Activation of vitamin D. The skin, liver, and kidneys participate in synthesizing the active form of vitamin D.
My student support system. Keep watching, keep learning.